Okay, if you set the total energy equal to the potential stored in a spring, right? So this formula is not in the data packet, right? But this says that the maximum kinetic energy equals the spring kinetic energy, right? Let's solve for omega. Well, that's easy, right? 1/2 m omega squared x naught squared equals 1/2 k x naught squared, right? So this is total max potential energy, max kinetic energy, right? They have to be equal because energy is conserved, right? Okay. Okay, so x naught squared cancels on both sides, right? 1/2 is not there anymore, right? So omega squared is k, and then I'm going to divide both sides by m. And of course, omega is square root of k over m. Okay? Yay! The other place that you can get this formula, right, is just from calculus itself, right? If x is equal to x naught sine omega t, right? If I take the derivative of this, right, dx dt is equal to velocity, right, is equal to, and then we just take the derivative of this. The derivative of sine is cosine, and then we take the omega out, right? So it's omega x naught cos omega t, right? This is what the chain rule or something like that, right? Okay, so we take the derivative of this. This is the derivative, which is of course the velocity, and then of course dv dt, time rate at which velocity changes, is acceleration, right? And then again we're going to take the derivative of cosine's negative sine, and we take an omega out again, right? Because it's the chain rule or something like that, right? And we get negative omega squared x naught sine omega t, right? Okay, so we get that the maximum acceleration is going to be omega squared x naught, right? Okay, and then of course if the if we go to force, if we go to dynamics, right, force is equal to kx, right? F also equals ma. So if we say ma equals kx, and really there's a minus sign here, right? Okay, then the acceleration is what, minus k over m x, and so the maximum acceleration would be, right, then we take away that, right? And then now you go, okay, look, here's one expression for acceleration, here's another expression for acceleration. If you examine them, you'll realize that omega squared is k over m, so omega is square root of k over m. I'm very sorry for ruining your brain. If you don't understand calculus, that's okay. You'll understand it by the time you take your IB test. Yay! Let's draw a perfect rectangle. Almost. It's almost perfect. Look at that, huh? That's amazing. How does he do that?